Hello, I'm Jairatna GUTNC under the registration number EG2020-3981. In this demonstration, I will showcase the Kafka-based order processing system built with Spring Boot. In this system, it implements serialization, real-time price aggregation, retry logic, and dead letter queue. Let's dive into the architecture and see it in action. So this is the project architecture. It has Algo schema, and in the config folder Kafka config and consumer and the order controller as well as producer and service. Also this has a Docker compose file. The system architecture consists of several components working together. First, we define our message schema using Apache Algo. Each order has 3 fields: order ID, product name, and price. Algo ensures type safety and efficient serialization. Our infrastructure includes Zookeeper, Kafka coordination, and Kafka broker for message streaming platform, and schema registry for manage Algo scheme, and Kafka UI for web interface monitoring. So let me start the Kafka infrastructure using Docker Compose. So all the containers are started. All the services are up and running. We have Kafka on port 9092, schema registry on 8081, and Kafka UI on 8090. Now I will start the Spring Boot application. So let's monitor our Kafka cluster using Kafka UI. This is the Kafka UI. Here we can see the topics. Here our main order topic. Here is our main order topic. We can see message being produced in real time, and partition and offsets. The Algo schema registered in schema registry. Let's view some messages. Each message shows the order ID, product name, and price in floating point. This is the schema registry. The schema registry stores our Algo schema. This ensures all product and customers use the same message format, preventing data corruption. Let's examine the producer logs. The order producer automatically generates every 2 seconds with sequential order IDs, random product for our catalog, and random prices between $10 and $1,000. Each message is successfully sent to Kafka, and we received the partition offset confirming delivery. Here, the producer uses strings at schedule annotation to generate orders, create orders object using the builder pattern and send them via Kafka template. Now let's look at the consumer processing these orders. This is the processing of orders. For successful orders, consumer receives the message, processing it, and update the aggregation statistics and acknowledge the message. This happens for about 90% of messages. So this is the aggregation stats. In every 10 orders, we see aggregation statistics showing total number of order processed and running average price calculate in real time and total revenue. This demonstrates our real-time aggregation capability. The system simulates a 10% failure rate to demonstrate retry logic. Let me show you a failed order. This is a failed order. When a temporary failure occurs, first attempt fail, it triggers retry mechanism and it waits 1 second and retry second attempt. If the order is eventually processed, it will be successful without data loss. This is the order consumer file. Our retry mechanism implements up to 3 retries, that means 4 total attempts, and exponential backoffs, and automatic recovery for transient failures. Sometimes orders fail permanently after all retries. These go to DLQ. So after 4 failed attempts, order is marked as permanently failed and sent to the order DLQ topic, and DLQ consumer logs it for manual review, and then original message is acknowledged to prevent blocking. Now let's send a message to a DLQ. So from this API we can send a error message. So I will send a order with minus 500 price, so it will be failed. So in the logs we can see by sending the order, it retry for 3 attempts and it go to the DLQ. So let's see it in the Kafka UI. In the Kafka topic, there is a orders DLQ topic, and here we can see the DLQ messages. So we can see the failed order is come to the DLQ. The system also provides REST APIs for manual testing. Let me send a custom order. So the order is synced successfully. The API accepted our order. Let's check the logs to see it being processed. In the logs we can see our order, the send order, processing order, and it successfully processed the order. Here we can see the statistics also. So we can see total orders, running average, and total revenue. The statistics endpoint show our real-time aggregation working perfectly. To summarize what I have demonstrated: euro serialization, schema-based messaging with schema registry, and real-time aggregation, running average calculated on fly as orders stream through, And retry logic, it means exponential backoff with 3 retries for transient failures. And DLQ, failed message isolated for manual review. And monitoring, Kafka UI for real-time visibility. And REST APIs, manual testing and statistics endpoints. So this system demonstrates the Kafka-based order processing system. Thank you.